Now I can complete the square. I've got that skill. I could never remember the cheat that I just derived for you. I could do the derivation, but I could never remember this. Um, but yeah, doing it in general. Hey, this is where the quadratic formula comes from anyway. Um, ax squared plus bx plus c. I'm just going to complete the square on this. Pull the a out. We know how to complete the square when the x squared has a 1 in front of it. So pull the a out of the first two terms, leave the c out over there, and you get this, x squared plus b over ax. Now, to complete the square, you divide this b over a by 2 and square the result. There it is, b over 2a. That's b over a divided by 2 squared. And I just added that, right? So I need to subtract that to keep this the same. And if it's an equation, this would be added to the other side. But right now I'm just keeping it as an expression. This expression equals this expression equals this expression, provided I subtract off this. Now why is that a there? That a is there is because this a is here. Because it's a times that thing that got added. So it's a times that thing that needs to be subtracted. Okay? And what do I have here? Look what we have. X squared plus b over ax plus b over 2a quantity squared. That's in the form of a perfect square trinomial, which can be factored into x plus b over 2a quantity squared. And then the a is outside just along for the ride, right? But this thing is equal to this thing. And so once I've written that, I've completed the square here. Add, or a times this, the a cancels with the a squared to give me just no a out in front and a 4a to the first in the denominator. So I have to add these together. 4a is the common denominator. So 4a over 4a times the c gives me 4ac over 4a. Got the common denominator 4ac minus b squared. And if you rewrite this, put a minus out in front and change the signs inside, you see the discriminant sitting right there. But anyway, here's the cheat, how to rewrite the left-hand side as a perfect square, or how to complete the square on the left-hand side in general. You just take the b over 2a and then subtract b squared minus 4a c over 4a. So you might be able to use that with a cheat sheet, but I don't do cheat sheets, okay? But this could be a check for you, and some of you might be able to memorize this. I don't know. I try to minimize what you have to memorize, quadratic formula and discriminant, biggies amongst them. But this formula, that's a little complicated. Anyway, let me show you how I would do completing the square to solve this one. I put this one in here. This is one that factors, and into x minus 3 times x plus 2. So it should be fairly simple looking answers when we get all done. But let's just go to town on it. X squared minus x, the coefficient of x is 1, divide that by 2, square it. And I'm going to add the 6 to both sides. Get that 6 over on the right. And I've just added 1/2 squared to the left, and 1/2 squared is 1 squared over 2 squared, which is 1/4. So 4 times 6 is 24 plus 1, 25/4. It's a good sign when that thing's a perfect square, which it is. 25/4 is the square of 5/2. Now, the left-hand side, I've tweaked it. I've done this game, so this will factor immediately as an x minus 1/2 quantity squared, and it's a minus there because it's a minus there. That controls that. Okay, that'll always be positive, always. But that controls the sign there. And that's equal to 25/4. And we better get an answer of +3 and -2 and we're all done. But let's see. Next step, watch all the steps I skip. There's an absolute value going on, blah, blah, blah. The very next step, x minus 1/2 equals plus or minus the square root of 25/4. That square equals the absolute value, square root of the square. is in there all the time. It's why the magic plus or minus arrives. But yeah, if you ever have a math tutor, ask them to explain that. And if they don't understand the connection to the absolute value, they're really not very good mathematicians. And they're really not very good teachers. Maybe they're good at faking it. Add a half to both sides. And I'm telling you, it's very common. And let me see, the square root of 25 over 4, that's the square root of 25 over the square root of 4. Square root of 25 is 5, and the square root of 4 is 2. So that's plus or minus 5 halves. 1 plus 5 all divided by 2 equals 6 over 2. There's my positive 3. And then 1 half minus 5. 1 minus 5 divided by 2. That's minus 4 divided by 2, and that's equal to a minus 2, just like we wanted, right? So x is in this set, and you're done with that problem. Again, if you can do it with a formula, but you better not get caught with a darn cheat sheet. And if you're going to use the formula from memory, you better have a damn good memory. And I'm telling you right now that if you've got a good enough memory to memorize this formula, why not use that same brain power to learn the skill? Because the skill requires far less in terms of memorization.